guys, my name is Nako Nakatsuka. I'm a fourth year chemistry PhD student at UCLA, and today I'll be helping you guys out by going over some general chemistry concepts. And good luck with the course. So organic functional groups are extremely important when talking about organic chemistry. And so functional groups can be added to any particular molecule and it gives it certain characteristics. So functional groups are super useful since they divide organic compounds into different groups that have similar chemical properties. And so let me read these two lines above right here, where it says functional groups are groups of atoms in organic molecules that are responsible for the characteristic chemical reactions of those molecules. In the general formula below, R represents a hydrocarbon group or a hydrogen, and X represents any halogen group. Okay, so we already went over alkanes, alkenes, and alkynes, and by looking at these pictures, you can see that the suffix is -ane, for example, ethane, and then for alkenes it's -ene, such as ethene, and then -ine for alkynes, such as ethyne. But now we can also talk about other functional groups such as alcohol, where for an alcohol you have a hydroxyl group, which is this OH group right here, and it has the suffix of -ol. And an example of this is ethanol. And so this is a very important guy to remember. A haloalkane means that you have an alkane with a halogen group. So this X represents a halogen, and you start out with the term halo before. And so this is actually a prefix. So an example of this is dichloroethane, which is an alkane with two chlorines, which is the halogen. And so this halo as the prefix just refers to whatever halogen you're using for that particular molecule. So this is also important. So we can also talk about aldehydes, which end with the suffix -al. An example of that is ethanol. And so you have to be careful to not mix up aldehydes and ketones. Basically, for an aldehyde, after the C double bond O, one thing is attached to whatever hydrocarbon chain you have, but there has to be a hydrogen right here. On the other hand, for a ketone, you can have two R groups. So this carbonyl group, which I'm going to write down right here, carbonyl, which is this C double bond O that both of these functional groups have, but it also has to have two R groups on either side for it to be a ketone. And the suffix for ketones is -one, for example, propanone. So carboxylic acid is a combination of a carbonyl and an alcohol. So you have the C double bond O and also the OH of the alcohol. You always end the name with oic acid. An example of this is ethanoic acid. And so whenever you see a COOH group in any molecule, you can always assume that it has acidic properties because it has a carboxylic acid group. We can also talk about esters. In the case of an ester, we have this carbonyl group, but we also have this oxygen in between the R groups. And you end with -ate as the suffix, and an example of it is ethyl ethanoate. In the case of ethers, you just have an oxygen in between two R groups without this extra carbonyl. So make sure you don't mix up esters and ethers because they're completely different. And so you always have alkoxy as the prefix for any ethers, and an example of this is methoxyethane. So an amide is when you have this NH2 group. And so in the case of an amide, you also have a carbonyl right next to it. Make sure you don't mix up amides and amines because amine has the NH2, but it doesn't have this carbonyl group. And so the name ends with amide, and for amine, it ends with amine. So that's pretty straightforward. But make sure you don't mix up these two. And finally, nitrile has this C triple bond N group right here attached to whatever parent chain you have, and you end with the suffix nitrile, such as ethane nitrile. And so all of these functional groups are the basics you're going to see in this chapter, and you should always make sure you know what the suffixes or prefixes are so you're able to name whatever compound is shown to you.